So welcome to the pre-recording of lecture 24, which is the second half of the 12th session at the beginning of week 5 in this 8-week course. So we have started the discussion on the design of larger programs and in particular the modular design. So the purpose of this second half is to give another example. Our program is still small, but it has the potential to grow into something quite large. So we are going to prototype a multiple choice quiz. In the second half of the slide presentation, I will define two models to develop software, and I will also say something about the quality aspects of software. Okay, so we have covered many computer literacy aspects in this introductory course. A lot of these concepts you can always look it up, but if you are a really good computer scientist, you know these concepts without ever having to look up something. So we can train ourselves and doing this in combining improving our programming skills. So we will have a program that shows a question and multiple possible answers. Now, there is some randomness in there, so even if we would have a limited choice of questions, for every question there are multiple answers and they can be shuffled in different orders. So we will be shown a question. The user will be prompted for a choice, one of the possible answers in our multiple choice course. The program will immediately give us feedback and give us a score on what we did. So this is a prototype. What we will develop in this limited time in this introductory course, but you can very well imagine that this could grow into something quite large if we already would like to code in everything that we have covered in this course. So this would already be a large collection of questions with possible answers. And we can also think about the administration. So when this would be administered via a web interface. So in some sense, what you would like to do with this prototype here is you would like to showcase the multiple choice quiz, the concepts of the program, how it would run and how it would be made, um, how it could scale up. Okay, so here is a screenshot. So what is the octal system? What is the base in the octal system? So we've seen the binary and the hexadecimal. So 16 and 2 are two possible answers. So there is the decimal notation, but of course octal means 8. So this is a good test, and you see that we got this correct. So at the very end, there is the score that is shown. So I immediately stopped this test and the score was given. So I have answered one question correct, 0 wrong. So my score is 100%. All right. What do we have in Python? We have the command line, we have the Python shell environment, so we have the command prompt, so our program will run as the previous, as on the previous slide. We have the data structures, lists, tuples, and dictionaries. We have the loops, the functions, and the branching statements. There are the random number generators, which make that even with a limited set of questions, we can generate many possible quizzes. What we also want is something that is already modular. You could, for this simple demonstration, you could still lump everything in one file, but we want to apply the good principles of software design. Information hiding, and there is something that we want to hide now, the generation of the questions and then the dialogue of the user. So again, what do we want to hide? What is at the bottom of our program? So these are the questions and the answers. So we can have the generation of the questions. We can decide this completely for any type of quiz. That is also what makes the design so flexible. That's also a part of making a design that it is extendable, so it should actually also work for any type of quiz. So if you want to learn another language, for example, because you're still going to travel this summer, then you could use this quiz for the same purpose. Um, so here is the bottom of our program. The bottom consists of the multiple choice questions. So depending on the subject, this is what somebody could focus on. So in this course, we treat computer literacy as the part. So then every question, and actually coming back to our computers as synchronous digital systems, everything is binary, everything is a string, and everything can actually be represented by numbers and strings. So uh, with the previous lecture, we had a stack at the very bottom that was a list. Now we will use a dictionary. One can also have a DBM file, and in a larger application, one would indeed have a database. Here it is just the questions and answers are just stored inside uh, a plain file, which is formatted with Python dictionaries. Okay, we will have the convention that the correct answer will come first. But in the multiple choice quiz, the, the possible answers will be shuffled. So there will be the alternatives, and the correct answer will always be the answer that's labeled 1 in the dictionary of the questions and the answers. So there is a coding of the question. So we have the question, and then we have the answers. So that's at the bottom. So we have the functionality. So we have the making or the coding of the quiz, how it is represented. But then there is also the dialogue. How do you want to prompt the user? How do you want to give feedback for the user? So in some sense, the module questions is more interested in the number type, the data type aspect of it. The dialogue is what it says, it's also the input and the output. So I will be using the same diamond layout as in the previous lecture. So still a very simple design. So here is then the representation of a question, of a multiple choice question. So we have the number of a question. So there will be, in my example, only 4 questions. So I will be showing in random order. So I will be showing question 3. And then of the 4 possible answers, the correct answer will be shown at the second position. So the list in that tuple, so the second item, also codifies what will the correct answer be. So if the user types in 2, then you can already verify the correctness of the reply, not knowing what the question is, only using the convention that if the reply turns up to be a 1, so this is, or actually we count still from 0, but I'm meaning the second answer here is a 1, and that is in the shuffling it was the correct answer. Okay, so this is the principle of information hiding. Also, the high cohesion. What the module questions is um, concerned about is on the randomness of the questions, the order of the questions, and the order of the multiple choice questions, of the multiple choice answers. Okay, so here is then the diamond design. So we have the generation of the questions and the dialogue of the users. So this quiz in its prototype is intended for English-speaking users, but if it goes to another language, then only the dialogue should actually be changed. The top program, the top is the user that will actually, in a loop, in a very simple loop, it will generate a question and then uh, prompt for answers, calling the prompt in the dialogue. The top level will essentially also store the tally of the correct and versus wrongly answered questions. Now the links here represent the dependencies. So assuming that the user of this quiz would have access to the source code of the automated quiz, then it can see that there is a module questions and there is a module dialogue, but it does not see, the user does not see the question and answer dictionary. So this is the concept of information hiding, which is also here kind of showing the integrity of the quiz. In databases, so in a high stakes exam, so access to the database would be only to privileged clients who could connect to the database via a password. The running of the automated quiz could be in a web client. So we have seen the client server computing. So there is the automated quiz here, a very simple Python program, which could be replaced by a web client. The generate questions and the dialogue with users would interact with the database server and could actually be seen as database clients. All right, second part. So I will, in the second part of this lecture, I will go through a Jupyter lab and also again another diagram. Let me, in the second half of this slide presentation, go back to the topic of software engineering. So there is the software crisis. We are still experiencing it. Software, producing good software is very expensive, and making good new software is also still something that costs. So whenever we all use software, and whenever you are subjected to version 1.0 of a software, then there are always problems. So the symptoms are that late delivery, so the fact that products are sometimes defective, is that it was already overrun in time and in cost budgets. And so here are some historical data. Um, so this is historical data, the 60s and the 80s. Um, so the problem remains that the automation of software creation remains very intensive. I'm not saying the standard types. We're talking here about original large software products, not something that has been done already. So it is really the process of creation. It's really the process of a creative process, which still requires a lot of human interaction. And there are tools that will help you for this, of course. All right, what do we say about quality? So when we talk about quality, we mainly talk about what we can measure. So then the industrial quality refers to a target value. So one and the target value is what one needs to reach, and one needs to reach the target on average, but also the standard deviation is very important. So in a search engine, for example, if you want to measure the quality there, you want a relevant answer or relevant answers on average within 10 seconds, but the standard deviation should then also not be 8 seconds, but preferably also very small. Um, so, in very short definition, something has high quality when it behaves as you expect. So we distinguish between quality of the product and also quality of the process. So you can have, for example, a very cool working program, but the documentation is absent or very difficult to understand. So there is the quality of the process. Uh, is the program not only working as behaved, but is it also written in a way that allows for uh, extension for maintenance? So there is this design documentation. So there are the internal qualities and the external qualities. What is now good software? First and foremost, also in this course, correctness. Correctness is translated in, does it meet the specifications? Does it satisfy the requirements? So every algorithm does something, but every algorithm is actually prefaced. There is an input-output specification there. So the algorithm can be correct if you don't look at the input-output. So in some sense, the computer never makes mistakes, but it may not deliver what was expected. The efficiency is very important. So we have the use of memory, the use of time. Um, and this is also, there is the complexity of the problem. So it can be that the problem is so complex that no matter how efficient you program, it will still take a lot of time. So there is the cost and the complexity side. There are two different words. Complexity is intrinsic to the problem. The cost is related to an algorithm. Can it be modified? So if something is very useful, then it wants to be used in other environments. So if you have, say, a nice program that runs in a terminal window, well, can you build a web interface for it? Can you extend it? So this very much relates to the design principles, the design for change. The modularity, so the high cohesion, makes that if you have done something right, so if you have the right design, you have the right module, then that module is so useful that it can also be uh, adapted to other situations. So the mathematical libraries are often cited as a typical example of reusable software. All right, how does one go about designing and making good software? Well, there are two different models. So there is the software, there is the waterfall model. Um, so first of all, one does a feasibility study, a cost-benefit analysis. You can see this a little bit about building everything, anything. If you want to build a new house, for example, you're first gonna check, can I afford it? So the cost benefit analysis of it, is the investment worth it? Um, then what are the specifications? So what are the requirements? What must it do? Um, so then what is the architecture? What is the design? What are the modules and are the relation between the modules? Then the implementation and the verification of the modules. So this is where the testing comes in. So in our example now, the main program is actually also the entire test. But typically one separates the module test or the unit testing from the integration testing. So there is the verification and then there is the validation. So step 6 is the installation. You have to deliver the software to the user. So the user, that this stage also actually involves the user that will accept the software or not. It could be that the programmers feel that this is a cool piece of software, everything works, but then actually during the installations phase, there is something really wrong. One can think of a situation where the software developers were working on computers that had terabytes of random access memory, whereas then the users are running this on an 8 GB random access memory machine. So there are problems. Then the last stage is the maintenance stage. So this is a waterfall model. Uh, Water flows downwards. So you first in the feasibility study, you go to the bankers, you go to the people with the money. Only when they greenlight the project can you think about what your system should do, um, and more in specific details. Um, there is feedback. There is the waterfall, but somehow when water falls down, there is still some vapors coming up. There is possibility for feedback. So if you have the green light on a cost benefit analysis, in the next step you may go overboard with the whole specifications, and you may come up with a system that is way too complex, and that cannot be is not feasible. So there are movements up and down. So if the software on installation is not accepted by the user, you can actually go back and to the previous step. Something probably must have gone wrong through the testing. So this system is not as inflexible as it is. Um, However, the spiral model is often advertised um, as a more flexible alternative. What it actually means that instead of delivering an entire product as the result of 6 stages, so it's only in stage 6 that you get to the user, you would already involve the user very early on. So you make requires, you make a prototype, and that is actually delivered to the user. So this is more an incremental development. Um, So it's also what is often called agile development. So you have to be um, capable of adjusting. So often a user may actually not entirely fully well realize what can be done and what is actually really needed. So the integration of the user here in the verification stage at each stages in the spiral has its benefits. Of course, also here it can spiral out of control. So whatever process that you're using, it can go wrong, and most likely it will also go wrong. All right, so today we will see the question and answer um, application. So the question and answer application is often, I often sometimes use it in a course as an additional extra last project to um, towards the final exam. It serves kind of both goals. You will review the course and then also um, make your automated quiz a little bit more interesting. You can develop just to make the point. So if you are want to export this to another domain, so here we have the first 13 states of the Union in the United States. So you can link the names of the states with their capitals and the year in which they joined the Union. So the questions, all the exercises are inviting you to play with the um, illustration for uh, this lecture. So I will go to the Jupyter notebook. So here you see the design. So it's the same diamond design as I introduced in the previous lecture. So the topic of software design is a topic of an entire different course, but still I want to illustrate some of the aspects. I mentioned last time the unified modeling language, and actually I learned that in the diagram. So there is this BPMN diagram. So this is the business process model annotation. I like it because it had this user on top. So it supports the diamond diagram, simple diagram that I want to um, demonstrate here. So we have four pieces in our software. So on top is the main program, and that will be just a simple loop. We will generate questions, so that's that module here. Essentially, this is the uh, random number generation, so the randomness. There is the dialogue with the users, and then there is the information that actually you want to hide from the top user, the user who takes this quiz. So there is this database of questions and answers, here represented by a dictionary. So this is the design. Then in the modules, I followed the same patterns as in the previous lecture, simply because it's an important pattern. So I haven't documented this with markdown cells, but you can see that I have a separate code folder that stores the Python scripts. So there are only 4 Python scripts, and they could have very well been um, in the current folder. But as is the case with larger programs, your code may be dispersed in separate folders. So I will insert in the front of my path the name of the folder where I have stored the code. So the path is the path from the sys module. So this is comes with Python. You can modify this as a user, as a Python programmer, and this determines the order in which Python is going to look for its modules. And in the Jupyter notebook, I can nicely show the interface of each module. So there is the questions module that will essentially hide the random number generators. So this is not a statistics course. Random numbers are already hidden to us, but also which type of random number generators that we are using and how we are using them, that is only of concern to this questions module. So if this is again, if this is a program where multiple programmers work on this, well, only the programmer who knows about the ins and outs of the random module will have to take care of this. So this function will generate, evaluate, and will actually update the tally, the number of correct and the so depending on the evaluation, so the evaluation will return true or false, and this will be passed to the update of the tally. So notice the high cohesion here, again with the randomness, but the low coupling. So the writer of this module, so if you look at this module, you don't know essentially that this is a computer literacy quiz. It could be any quiz. Okay, so then the dialogue. The dialogue will prompt for a choice, will show the outcome, will also show the question, and will show the tally. So in essence, everything that is language dependent, so everything that should be changed if you would be going to another language, if you other than English, then this is something that should be changed. So this is again showing the high cohesion and the low coupling. So if you write this dialogues, you just have to know to prompting a choice here. So there are type in a number. So and that number here, I have four alternatives, but it could be only two alternatives. In this quiz, it's not even fixed. So you can have also the showing of the outcome. So the outcome is given by a Boolean variable. So it only knows true or false. It's kind of it gives the proper message. It's only here with the showing of the question, the numbers and the possible order, the order of the multiple choice questions, that it will go into the dictionary and display then the dictionary queries. So the strings that correspond to these definitions here. Then the showing of the tally, right and wrong, number of right and wrong questions. So this is in some sense, the functionality of the module, what the module exports for functions. Here you see the question and answer. So this is something that I can import, and here you see the four questions that are in there. So the previous two modules, they exported functions. Here, this module Q&A exports dictionaries. It exports a dictionary with questions, and then it exports also a corresponding dictionary with answers. If you want to do even more information hiding, you could still split the questions from the answers. So here are the four questions. Here you see the possible answers. So we had in the slides the octal, but then there are about the developers. Rashi Gupta was a textbook author of one of the previous runs. Here is what does a compiler do. So four possible answers. In this computer literacy quiz, you can of course check, but and you know that the first correct answer always comes first. So it's also actually telling you what a compiler does. And then there is the main program. So in this Jupyter notebook, this is very nice to scroll through the interface, but it's actually not so nice to run programs. So let me go to the terminal window. So I have actually now a little bit more time. I can run this program as Python. Actually, I should go into the code folder. So there also you see again the underscore underscore py cache underscore underscore. So this folder collects the imported. This is the result from the imports. So I imported in my Jupyter notebook 3 modules, and it generated bytecode, and the bytecode was stored in this py cache. Typically, you don't need to look at this, but if you are changing your Python scripts, and if the imports are not really refreshed, so if the Python code is not um, updated, then it may be frustrating that you think that your changes don't have any effect. So this is kind of a warning a little bit. So let's run the quiz, and here we have the octal, and now it is 4, so this is the correct answer, and the main developer from Python say that I think it's John van Neumann, but this is wrong. So actually I didn't want to continue, so it indeed is the correct answer, and I do not want to continue. So I had 2 questions right, 1 wrong. Okay, so let me now go to the code itself. So I will go to the code folder and click at the main program. So here the main program is not even stored in a main function. The point is that this um, main program is actually responsible for the shuffling of the answers. So there is the possibility for cheating, or there is the possibility for, yes, indeed, for showing the correct answer. So one can, and there are design questions here. One of the extensions in the questions asked to give feedback. So let me go to the slides again. Um, so modify the program so the user has the option to see the correct answer when wrong. So this is the second question here. If you look to the generation of the quiz, the shuffle on the list will change the order. So let me demonstrate this. So so from random import shuffle. So I will generate a list of 10 numbers. Now if I shuffle the list, then you see that this is a function that has changed the list. So functions applied on lists can actually also change the list. So this is an example again of call by reference. But I just wanted to demonstrate the usefulness of the shuffle function, which is actually not really a function in the proper sense. It changed the list. So if you want a random order, so the opposite is now to sort. So the sorting that has to be done via a method. And so it's shuffle is kind of the unsort, if you like. Okay, so let me go back to the main program. So the main program will maintain as a global parameter the tally. So the tally is updated here. So actually I'm returning the list, not changing the list, but updating the tally, returning a new tally, a new list essentially. Um, you see the import. So we can, from a module, we can also import a particular function. So an alternative way of writing would be from dialog import prompt choice. Then I can just write prompt choice. This has the virtue that you can see your main program, what function does it execute from which module. And I speak from experience, if you have a very complicated library and if you have imported everything from all the packages that you're using, then often it's very difficult to figure out which function from which package is actually called. Um, this makes this very clear. So you have a generation of the question, you have the shuffling. Again, the shuffling is interesting. So there is here the prompting to continue. So in some sense, the design is also not entirely consistent because this continue should actually have been included in the dialogue. The dialogue should have included this question as well, just as an encapsulation, making sure that you separate the concerns. Now, if the language is changing, I also have to change the main program, which is essentially bad. So the tally is shown at the very end. Perhaps you can, so in a more adaptive multiple choice question, if the user does very well, so you could classify your questions in beginner questions and more advanced question. If the in the tally, if you see that the user, you can start at the middle level, but then downgrade to easier questions or to harder questions depending on the score of the user. So there are many possibilities for extensions here. Okay, so let me show now the bottom. Here you see the bottom. This is Pythonite, so this is good in a Python environment, if and good for prototyping, a good application of Python. But if you would go to a real world application, then there would be an underlying database in this. So you could still use DBM if you stick with Python, but it could be that you are going to use another database, and then this would be replaced by the database tables. So you would have, so perhaps we will talk a little bit about databases later, but a database consists of several tables. So you would have a table with questions and you would have a table with answers. So here is at this stage, if this would grow into a larger application where a database administrator would come in. Um, there is the logic of the questions. I moved out the shuffling. So the shuffling was still in the main program because it might be that indeed in the main program you may want to decide to give feedback. So actually the main program should know the correct answer if that potentially could lead to cheating. Um, um, if you give feedback, then you will need to show the correct answer. So you could then directly import in the main program, but you could also provide an interface. You could have that the dialogue, so I'm going to the dialogue here. So the dialogue should essentially be extended with the continue. But here you would have the showing of the answer. So in order to make a better implementation, so in this solving of the second exercise here, you could do everything in the main program, but it is a better design that you extend the dialogue. That in the dialogue you have the show question, but you also have the show answer. So here in the dialogue you have the showing of the question, which displays the question and then displays all the possible answers. And this happens after the shuffling. So it would be wrong to include the shuffling here. So what this module does, it's mainly displaying strings. It's displaying strings and it is prompting for strings. This would be extended also with exception handlers. If the user does not type in a number, then you may want to make the program more robust that it doesn't crash. Here is also the feedback. So in having the wording on how you have the feedback, so you would essentially also extend the show outcome. So this would be wrong, please try again. Here would be wrong, the correct answer is, and then you would show the answer for that particular question. So you would extend the showing of the outcome. You can do this with an optional answer, an optional argument that you could still say if the option feedback is there, then you will actually show the feedback. So you can, when you extend a program, you can extend it so that previous versions don't have to be modified as well. So we have seen how to add optional keyword arguments to a function. This is very useful by adding additional options without breaking the original design. So if show outcome is only shown with is only called with a boolean, then it's still fine for the design here. You won't see the feedback. So this question is not so easy, so difficult to answer question two. But if you think about what needs to be modified and how to do this in a very responsible and robust way, then it requires some reflection and some thinking. Okay, I have shown the modules. I have shown the main program, and um, I think that should be about it. Let me navigate to the um, main design again. So we have this diagram, which is kind of the diamond design, a very straightforward design, which could be very useful for prototyping with Python. A prototype that kind of already invites to think about separate uh, complexities, that separates the complexities in any automated quiz. Okay, so I'm 2 minutes shy from the 50-minute mark. I think I have explained everything. So please think about the exercises. We can already write very interesting and useful Python scripts with what we know.